Hey there, my name is Peter.
And I'm Rosalind. In the last episode of Better Safe Than Sorry, Rachel and Sam showed you how to limit access to your application's data by using security rules. Security rules are a key feature of Firebase authentication and help you to make sure users can only access their own data that is stored in Cloud Firestore, cloud storage, or the real-time database. Security rules play an important role in keeping your users and their data safe and secure.
But trying to read or manipulate your users' data is not the only way someone can attack your application. Another attack vector is traffic. Specifically, traffic that's not from real users. Usually, more traffic is better. It means more users are using your app, or your users are using your app more. But sometimes, more traffic is not better. And today, we will discuss why some traffic might actually be unwanted and what you can do about it. Let's look at this architecture diagram from the first episode. You can see that clients like your application can directly interact with Firebase services like Cloud Firestore or cloud storage. This is possible because these services are directly accessible via the internet. And this is one of the reasons why it's so easy to get started with Firebase. All you need to connect is the root URL of, let's say, Firestore and your project ID.
But this also means that anyone who gets hold of your project ID and API key, which is not too hard to do in a web app, can go ahead and poke around at your app's backend to see what they can find. Now, I know you're thinking, I've watched Rachel and Sam's video and implemented all the best practices for security rules. I'm good. Well, not quite. This means a malicious actor will not be able to harm your users by reading or modifying any data in Firestore, real-time database, or storage. But they might still be able to cause you, the developer, some pain.
Here are some consequences you might face if a malicious actor probes around in your app. If they call your cloud functions, that will cost some amount of money for every invocation. Your security rules might need to read some values from the database to determine if the caller is allowed to access the requested data using GET or EXIST calls. That also costs a tiny bit of money for every read. And keep in mind that in your security rules, you cannot tell a legitimate user apart from a malicious actor. Another issue is that someone might try to saturate your backend by making many calls in a short period of time. Firebase has a lot of capacity, so your app will still be available for your users, but all those requests will still cost money, and you might be in for a nasty surprise at the end of the month.
Pro tip: you can set up an alert in the billing section of your Firebase project to receive a warning when the budget you set for your app is exceeded.
That's a very good point. But on the other hand, if all this traffic is not coming from legitimate users of your app, why pay for something that you didn't ask for in the first place? And that's why we built AppCheck. AppCheck is an extra security layer that blocks unwanted traffic from reaching the backend services of your app. It works a bit like a shield from sci-fi stories. When you turn it on, it will inspect all incoming traffic and will only let traffic coming from your own apps pass through to the backend. No matter if the unwanted traffic comes from a 12-year-old who has just discovered what curl is, or a malicious actor who wants to steal your data, if the request isn't from your app, they will just get a HTTP 400 bad request. To be able to tell a legitimate request apart from someone who is just trying to probe around in your app using curl or some other networking tool, AppCheck requires all requests coming from your app to be attested. This means that someone needs to say, yes, this request comes from a legitimate app. So you could say that Firebase authentication is for authenticating users, and Firebase AppCheck is for authenticating applications.
Okay, so how does AppCheck work? How can you authenticate your app, and how does AppCheck know that traffic coming from your app is legitimate? Let's first look at this diagram. Here, we see your app's backend protected by AppCheck, and here's a legitimate client app. To prove it is legitimate, it sends an AppCheck token with each request. The app check layer on the backend verifies the token and lets the request pass through if the token is valid. To create an app check token, your app uses a so-called attestation provider that you can set up in the Firebase console and integrate into your application code. Now let's take a look at what happens if an illegitimate app tries to access your backend. Since the illegitimate app doesn't have an attestation provider registered with your backend, it won't be able to obtain a valid app check token. Since it doesn't have this information, this app cannot attach a valid attestation token to your request it sends to your backend. On the backend, Firebase inspects the incoming requests. It notices that some of the requests don't have a valid attestation token, so it rejects them. This effectively prevents an attacker, or a person who is just probing around, from accessing your backend in the first place.
Cool. So now that you have a basic understanding of how AppCheck verifies if requests are coming from a legitimate app, let's take a quick look at how you can enable AppCheck for your project. There are 3 steps. First, you need to configure AppCheck for your project. In this example, we want to enable AppCheck for an iOS app that is already part of our Firebase project. To do this, we will go to the AppCheck page, select our app, and then choose one of the attestation providers. We will use app attest, as this is the easiest to set up. You just need your team ID. This is your iOS development team ID, and you can find it in your Apple developer account. Second, once you've done this, go into your Xcode project and enable the app attest capability. This will produce an entitlement file in the root folder of your project. Open this file and turn on production mode. Third, then go into your app delegate or the add main entry point of your app and add the following line to initialize AppCheck when your app starts up. And that's all you need to do to prepare your app for AppCheck in your iOS app. The only thing left to do is actually enforcing AppCheck in the Firebase console.
So when should you start enforcing AppCheck in your app? Keep in mind that once you enforce AppCheck for your project, all requests need to have a valid AppCheck token in their headers. Otherwise, they will be rejected by AppCheck on the backend. This is absolutely what we want for any new application. But if your application is already installed on hundreds or thousands of your users' devices, you want to avoid a situation where some of your users can't access your app because they're using an older version of the app that doesn't make use of AppCheck yet. So what's the best moment to flip the switch and enforce AppCheck? Well, ideally when all, or at least most, of your users have the new app version installed. But it's hard to tell when most of your users have installed the most recent version of your app. To make this a little bit easier for you, we've added a little dashboard to the Firebase console. This dashboard shows all the requests coming into your backend and how many of them are verified by AppCheck. Here, you can see how many requests are verified, how many might be coming from older versions of your app, how many are missing the AppCheck token header in the request, and how many have an invalid AppCheck token attached. So by looking at this dashboard, you can decide when is a good time to enforce AppCheck. If most of your requests are coming from the unverified, outdated client category, you'll probably want to hold off on enforcing AppCheck until more of your users have updated. However, if a lot of requests are coming from the unverified unknown origin or unverified invalid categories, this is a good indication that you have malicious traffic, and you'll want to enforce AppCheck to block this traffic. If you start working on a brand new app, we would recommend adding AppCheck right from the beginning so you can enforce AppCheck right from the start.
One thing to keep in mind. Some attestation providers have quotas for the number of daily calls you can send them. So if you suspect you might be onboarding a lot of new users, consider using remote config to gradually roll out the use of AppCheck to your users. Our documentation has more information about the quotas and limits of the attestation providers for your platform.
In the previous step, we configured AppCheck for the real-time database, but other Firebase products support AppCheck as well. You can use it with the real-time database, cloud storage, Cloud Firestore, and Cloud Functions. You can even use it with your own custom backend that doesn't even run on Firebase. So let's take a quick look at how to use AppCheck in Cloud Functions. You can call Cloud Functions from your client application or from other Firebase products on the backend. For example, you can call a Cloud Function whenever a new user signs up for your app, or when someone creates a new document in Cloud Firestore. We call these triggers, and as they are called from another Firebase service, we can safely assume that they come from a trusted environment. However, when calling a Cloud Function from a client app, we can't trust this as much. Remember, someone might have your API key and may try to probe your backend. To protect callable functions using AppCheck, we need to add a few lines of code to the beginning of those functions. If a request sent from your client is verified by AppCheck, there will be an additional field in the context object of the call. To check if the request is verified, you can check for the presence of context.app. If this is undefined, the request is not verified, and you should return an error.
Let's finally look at how you can use AppCheck with your custom backend. For example, you might run a content management system on your own server, and you want to make sure that only your genuine apps can communicate with this CMS. There are two things you need to do. Firstly, send a valid AppCheck token with every request from your client apps, and secondly, verify the AppCheck token in your backend code. Let's take a look at the client code first. After you get a fresh AppCheck token from the AppCheck client SDK, you add it to a header of your request. Here, we are using X Firebase AppCheck, but you can use any name you want. It is best practice to start custom header names with X- to avoid collisions with existing header names. On the server, you can then extract the header field from the request and verify if it's valid. If the token is not present or invalid, you should return a HTTP status code 401. This indicates that the client request has not been completed because it lacks valid authentication credentials for the requested resource. Using these two steps, you can protect your backend from malicious actors using AppCheck.
So today you learned how to use AppCheck to protect your backend. Let's summarize. AppCheck and security rules are two security features in Firebase that help you to protect your app and your users' data. They might sound similar, but they serve different purposes. Security rules make sure users can only access the data that they are allowed. For example, you can use security rules to make sure users can only read and write their own tasks in a to-do list app. AppCheck has a different goal. Its purpose is to protect your backend from any unwanted requests. This protects you from nasty surprises at the end of the billing period. By enforcing AppCheck, you block all requests that don't come from your genuine app. When building a new app, you should turn on AppCheck as soon as possible, preferably before you have real users. If you want to add AppCheck to an existing app, you can use the AppCheck dashboard in the Firebase console to see when most of your users use a version of your app that supports AppCheck, and then enforce AppCheck. AppCheck supports real-time database, Cloud Firestore, cloud storage, Cloud Functions, and even your custom backend resources. We will add support for more Firebase and Google services in the coming weeks and months.
Awesome! AppCheck and security rules are two important tools that help you keep your app and your users safe and secure. Next time, we're going to talk about passwords and why using email and password authentication might not be the best way to onboard new users. Thanks for watching, and stay safe.